Hello, my name is Abigail Rodriguez, and this is the demo of my homework. So first we need to log in as root. Next, we're going to turn off the randomization of the stack. Then we're going to compile our stack.c file. As you can see, we're saying that the stack needs to be executable, and we are turning off the stack guard. Now we're changing the permissions of the stack file. Next, we're going to compile our exploit.c code. Now we run them. And we spawned a new shell. Cool. And as you can see, I have root permissions. Okay, but now I want to exit out of this to show you the next task. So I'm skipping over task 2 because that takes a while, longer than the rest. So in this one, once again, I am going to turn off the stack randomization. And then I'm going to recompile stack.c, but this time I am not turning off the stack guard. Changing file permissions. Okay. So as you can see, stack smashing was detected and it was terminated. It didn't let our shellcode run. Since we turned on the stack, we left the stack guard on, it was able to detect that we were trying to smash the stack, and it terminated our program. Stack guard, what it does is it detects when you're trying to overflow the buffer, which is what we were trying to do. So that's a good way to prevent buffer overflow. Okay, now task 4. Sorry, let me clear this up for you. I'm going to turn off randomization of the stack again, recompile our stack.c. This time we are saying that our stack is not executable, so stack doesn't have permission to run an executable file. This time we are turning off the stack guard. We don't want it to detect that we were smashing the stack. And we got a segmentation fault because the stack was trying to run something that was executable when we told it it wasn't going to be executable. So that's why we got that error. Okay, now we're moving on to task 2, which is the one that I had skipped. So in this task, we turn the randomization of stack back on. This basically has the stack start at different positions every single time we run stack.c. So it makes it harder to guess where the return address is located. Okay, and we are recompiling stack.c. We're saying that it's going to be, we want it to be an executable stack, and we're turning off the permissions. We're turning off the stack guard. Changing the permissions. And then we can run our stack, and we got a seg fault because we were unable to correctly guess the position of an address in the buffer. Okay, so we're going to run a while loop to continuously rerun our stack file in hopes that we eventually guessed right. And since each time it runs, like I said, we start at a different position, so hopefully eventually our guess is correct, and then we will be able to spawn a new shell. Okay, so I will run you through my code quickly while this runs. Okay, so this was provided for us by the professor, and then here what I did here was use assembly language to be able to get the return address for the top of the stack. This was also given to us. The declaration of the buffer is 517. Our file, here we are storing no op instructions in filling up the buffer with no ops. Okay. And then here we want to find the location of the shellcode inside the buffer. So it will be located at the end of the buffer. So we do size of buffer minus the size of the shellcode +1 to account for the null character. Okay, and then we want a pointer pointing to the buffer, and we want to typecast it into a long. So here I'm printing out the address of the buffer, and then here we are randomly guessing an address located inside the buffer, in hopes that we hopefully land on a no-op operation, and that will eventually run our shellcode. And here all I do is print out the address of the top of the stack. Here I print out the return address of the guess we made. The return address, I calculated it by using the top of the stack, the address of the top of the stack, and offsetting it by offsetting it a bit in order to, like I said, hopefully guess some address inside the buffer. And then here I have a for loop that will fill our buffer with these guesses that we made. I calculated this by using the buffer size plus the length of str copy, which is 4 words. Buffer size is 24, as we saw in stack.c. So that's how we know. How many spaces we need to fill the buffer with, and then at the end of the buffer we need to fill it up with our shellcode, and that's what I'm doing here. And then here I'm telling strcopy to stop storing the contents when we reach the end of the file, and here was given to us. So and as you can see, I had it running for a while and it still doesn't spawn a shell, and unfortunately I did not have enough time to successfully spawn a new shell, because I would probably have to have this running for several hours, and like I said, unfortunately I did not have enough time to keep it running until I finally got the shell to open. So that's the end of my demo. Thanks for watching.